So exercise 70, question number 6. Let's just have a look at this particular one as an example of how you might set out the problem and use the formula that's involved here. So if we read it, you've got a trapezium, and it's the area is 13.5. So I don't know what shape the trapezium is going to have, but whenever I have a problem, particularly when the problem starts to get more complex, I'd always draw it. So the area is 13.5 square centimetres. The perpendicular distance between its parallel sides, these are the parallel sides of the trapezium, and we use these little arrows to denote that they're parallel. It's 3 centimetres, so I know this distance here is 3 centimetres. If the length of one of the parallel sides is 5.6, but I don't know which one's going to be, I'm trying to find the other one, so I don't know which one it is, but so let's make it the top one, doesn't really matter. Find the length of the other side. So I'll label the thing I'm after as X. So I've drawn it now and extracted out the information. That sometimes helps me to see where to go with the problem. And then, well, it's to do with the trapezium, so then I'll try and remember, or I'll look up the formula for the area for trapezium, and that's a half A plus B times the perpendicular height. And if you're interested, actually, there's a little extension activity for someone who might be interested in, where you could actually suss out statistically, because we've been doing things like averages, where this formula comes from. This half AB is a sort of an average. So you could probably work out for yourself where that formula comes from, but there it is anyway. So now, the reason why I want to look at this question is because there's two approaches from now on. We can either leave it as a formula and rearrange the formula for, well, if we're going to call these A and B, so this would be side A, say, and this would be side B, so actually we need to rearrange that formula for B and then plug in the numbers, or we can put the numbers in as it stands and then treat it like a little equation that we've got to solve. And we will be looking at solving equations. So I want to go through these two ways of doing the same question. So let's divide up the board into two, and I'm going to attempt it both ways. So the first way I'm going to do it is by the formula method. So I'm going to rearrange the formula. There it is. A equals half A plus B times H. And we've been looking at this sort of thing. We're after B. So we've got to undo it step by step. What might be a good thing to do first? That would mean multiplying everything that's outside the bracket by what's inside the bracket. So yes, we could do that, but I would not do that. I'd get rid of the other things that are outside the bracket first. So I might do what? Times by 2 to get rid of the half, right. Remember, finding half of something is the same as dividing by 2, so multiply by 2, and I'll have 2A equals A plus B times H. So that looks better. Now what? Somebody else. At the back, what would you do next? And remember, we want to leave B on its own on the right-hand side. So what's the next thing to get rid of? Again, if we get rid of the brackets, we'd have to multiply that and that by the H. So it doesn't really help. If we look at if you're not sure what to do, I always ask, well, what was the last thing that happened? What happened to B? A was added, and then the whole lot was multiplied by H. So the last thing was, it was all multiplied by H. So get rid of the H by dividing, okay? It's these sort of things that go through my head when I'm trying to work it out. So divide by H. 2A over H equals A plus B. And now we're almost there. What's the last step? We've got times. We want to take away the A. So B equals, now I'm just writing that on the right hand side, 2a over h minus a. So I've subtracted the a from both sides, and I've rearranged the formula to find b, which remember is an Rx. So now we can just plug in the numbers. So x equals, because that's what we call the unknown, 2 times the area, which is 13.5, over the height, which is 3, I think, yep, minus a, which is 5.6. And then I plug that into the calculator in one hit, and I'd get x equals 3.4. So in fact, I've labelled the wrong side because it's the shorter side that's b, but that's not really that important. You have to make a guess. The other way to do it is to form an equation. In other words, we just rewrite this formula but put the numbers in. So 13.5, which is the area, equals half times a, which is 5.6, minus b times the height, which is, sorry, I say minus, plus b, times the height, which is 3. And then try and solve it. And you do the similar sort of steps when you're solving it. I'd first of all multiply by 2 by getting rid of the half. So what's 2 times 13.5? 27 equals 5.6 plus b times 3. Then I would divide by 3. 27 divided by 3 is 9. Gets rid of that 3, so 5.6 plus b. And then finally subtract 5.6 from both sides, and I get b equals 3.4. Same answer, different approach. Which is best is an open question. It depends on the problem. Okay? I always like to try and rearrange the formula if I can, because then I've got a general formula to find b for any area, height and other side, and so I could then investigate what happens if I change those values. So this is the formula is in the end a good way if you want to investigate the effect of changing certain variables, for example. But if you've just got a one-off to solve, then you can set out an equation and solve that equation. So, page 162, we've got these formulae for finding the surface area and volume of some common shapes. If we look at them, first one, rectangular prism or a cuboid. A prism is a name given to any shape that has a uniform cross-section area. So in other words, if I were to cut this cuboid anywhere down its length, I would find the cross-section area would be the same. This would be the cross-section area here. So that means actually that the cylinder too is a prism. If I cut the prism, this cylinder rather, anywhere down its length, the cross-section area would be the same. And for the volume of any prism, so it could be a hexagonal prism, so the end is a hexagon, the volume is always the area of the end times the length. So if we look at number 1 here, it's the area of the end, which is the height times the breadth, h times b, multiplied by the length, gives you the volume. If we look at the cylinder, it's the area of the end, pi r squared, times the length, pi r squared h, and so on. So what's the volume of a cylinder? Pi r squared times the height. So it's a formula that I'd expect you to remember, because you know the area of a circle. All you've got to do is multiply by the length and you've got the volume. The pyramid, it's a third of the area of the base times the height. So this is a square pyramid here. The cone, the volume is a third of the area of the base times the height. So a pyramid has that sort of formula associated with it. It's a third of the area of the base, whatever it is, in a square pyramid or a cone, times by the height. The height again being the perpendicular height. So Pythagoras might well come in again, particularly with the cone. The sphere, 4/3 pi r cubed. So those are some common shapes to find the volumes of. What I want to focus on, though, for a few minutes is finding the surface area. If we look at this first one, somebody tell me where this formula comes from for finding the surface area of that shape. Why is there a 2 there? Sorry. Yeah, that's right. There's a pair of each face. If you look at the end, h times b, there's 2 ends. If I look at the side, L times H, there's 2 sides, and so on. So what's happened is I could have written 2 times BH plus 2 times HL plus 2 times LB for the surface area of that shape. And then, remember, we've been talking about factorizing. This is an expression to describe finding the surface area of that shape, an expression. Algebraic statement, if you like, saying what you've got to do to find the surface area of that shape. I've got 2 of those, 2 of those, and 2 of those, so I can, that element 2 is common to all 3 terms, so I can take it outside a bracket and factorize and end up with 2 times BH plus HL plus LB. So in other words, once I've got my expression, I can try and simplify it, and that's what's happened here. However, I've got to be aware of this formula, because this formula assumes I'm finding the area of both ends, both sides, and the top and the bottom. If this shape was attached to something else, say, some bigger cuboid, and I wanted to find the surface area of the compound shape, which is what you're going to be asked to do, for argument's sake, I might want to spray this with something to protect it from rust, if it was steel, I would not include that end of this cuboid, would I? See that? So if I just use this formula as it stands, use this formula as it stands to find the surface area, I'm going to get a wrong answer because it's included the hidden end. So these formulae for the surface area of the shapes come with a health warning. It assumes you're finding all the sides. If this was an open-ended cuboid, you wouldn't use one of the top and bottom shape sides. Look at the cylinder. Look at the formula for the surface area of a cylinder. How is that made up? How is that made up? How is this formula made up? Yep. Yeah, exactly right, yeah. So let's have a look. 2 ends, 2 pi r squared. So if it's an open-ended cylinder, then we don't include those ends. We only include this part of the formula here. And how is this made up? So you actually went further than I was expecting you to and explained this. If you look at this, you imagine you've opened out this cylinder and opened out the sides, you end up with a rectangle. And so this side is going to be h, but this side is going to be the circumference of the circle, as you were saying. And the circumference is 2 pi r, or pi times the diameter. So that's where this formula comes from, 2 pi r times the h. So again, if you've only got the top or the bottom, you have to adapt this formula. And the same argument can be applied to the surface area of the pyramid and the cone. It depends on this one. Look, if you look at this, pi r squared is the area of the base. So if the base is not included, you only use that. That's the area of this curved side. Yep. So now, same procedure, please. If you're on this page, if you flip on to the exercise 78, page 164, you could try some of those for me, please. If I give you about a quarter of an hour on this,